Turbocharging is actually a pretty simple concept. The objective here is to convert the energy contained in your exhaust stream, which would normally go to waste, into positive pressure within the intake manifold, forcing air into the engine and thus producing more power. The turbine. Basically, the turbine takes excess heat and pressure from the engine and turns it into a force. Without this element, the wheel would not work. There are two different parts of this specific element of the turbocharger. The turbocharger must have the correct turbine. If the turbine is too small for the engine, it would cause excessive back pressure, ultimately causing the engine to choke and lose power. If the turbine is too large, it will lag greatly and make it difficult for the booster going forward. If you liked this video till here far, please subscribe to my channel and press the bell icon to get new video updates. The compressor. The compressor is one of the most common elements of the turbocharger that people know and understand. It's made up of two parts, the compressor wheel and compressor cover. Ultimately, what these two parts do is compress the air and move it into the throttle body. The intercooler. This element is extremely important. The entire turbocharger product wouldn't be able to work correctly and safely without it. Basically, what the intercooler does is cools down the turbocharger, pressured air at intake. This is necessary because when the pressure increases, heat is created. An abundance of issues would occur, and too much heat can be harmful and dangerous. The wastegate. Another important element of the turbocharger is the wastegate. The wastegate allows for the regulation and flow of the exhaust gases, as well as the diversion of the exhaust gases to regulate turbine speed. When this is done, it also regulates the rotating speed of the compressor. Fundamentally, without the wastegate, the turbocharger wouldn't work properly. Center housing rotating assembly. The center housing rotating assembly, or the heart of the turbocharger, is also known as the CHRA. The CHRA is one of the most critical parts of the turbocharger. This element serves as the mounting point for both housings. With this being said, it must be made of heavy-duty or substantial material in order to do the job correctly and not be damaged by heat or turbine stress. Piping and manifolds. 3 different sections fall into this category. These categories include manifolds, the hot side, and the cold side. They are combined of pipes and runners that collect the exit gases and tunnel them into a merge collector. Due to the extreme temperature change, back pressure, and high stress, these need to be built and sized correctly. If they're not, the pipes and runners won't work, causing issues within the whole turbocharger. Blow-off valves. This element, known as the blow-off valve, is located on the compressor side of the turbo system. The blow-off valve relieves pressure from the turbocharger. After the throttle blade shuts, the blow-off valve dismisses the excess pressure. It just has one simple job, but it's a necessary component. Hot side piping. Gases move both from and to the turbocharger, and they move through something called hot side piping. Because of the harsh temperature of the gases when transferring the exhaust, hot side pipes must be made of strong material. If this isn't done, the piping won't withstand the heat accumulated during the transfer. Stainless steel is recommended for this process. Cold side piping. Cold side piping is any of the piping that moves compressed air from the turbocharger to the throttle body. The intercooler that we discussed above would fall into this cold side piping area. This is another aspect of the turbocharger that tries to reduce and regulate heat. The world of turbocharging has about as much variety as engine layouts. Let's take a look at the different styles. 1. Single turbo. 2. Twin turbo. 3. Twin scroll turbo. 4. Variable geometry turbo. 5. Variable twin scroll turbo. 6. Electric turbo. What are the advantages and disadvantages of turbocharger? Advantages of turbochargers. 1. Improved torque at low RPM in the case of diesel engines, and over a whole speed range in the case of petrol engines. 2. Better mixing of air and petrol in the case of petrol engine, resulting in effective pollution control. 3. The engine runs smoother and quieter. 4. Reduces diesel knock. 5. Ease in starting from cold. 6. Less smoke during low-speed acceleration. 7. Improved horsepower in the case of both petrol and diesel engines. Disadvantages. 1. Entails better cooling system. 2. Design becomes expensive and complicated. 3. Wear and tear is at a faster rate. How do you install a turbo on a non-turbo car? Installing a turbo on a non-turbo car is going to take a lot more than just plugging in a new part. That said, it is possible to add a turbocharger to just about any naturally aspirated NASP engine. But here's why you should think twice. Turbocharged engines don't just take in air differently than NASP engines, they do everything differently. Adding a turbocharger means cooling the compressed air, modifying the ECU, upgrading your clutch, possibly upgrading your fuel pump. Keep in mind, if you're able to tune everything just right, you might be able to get a little more horsepower out of your NASP engine, but the extra strain on your engine will likely cause it to deteriorate faster. Pro tip: a few companies, like Fly and Miata, have tried to simplify the process with a complete turbo kit, but it's still a very labor-intensive process. You'd be better served both in performance and dollars spent to source a turbocharged engine and have your mechanic install it. This can get expensive, but you'll definitely get more bang for your buck.